All right, what's going on, you guys? Module 2, Section 3, last one for Module 2. All talking about functions, linear, quadratic, and exponential, all your big three for TSI. So let's get into it. A couple things here with function notation. Be comfortable with this. I don't show a question here about actually evaluating function notation. I'll talk about it here in a little bit, but definitely do some practice about this part. Definitely do that practice in Canvas as well for that. Okay, so with function notation, they do care about two parts. Actually figure out a number, but what does that number actually mean? So in this case, if I was to ask you a number 1 or number 2, what does that mean? Well, let's look at the situation. The height of a weather balloon is modeled by h of m equals 450 plus 1200. Off the bat, doesn't that look like a linear equation? Y equals mx plus b? It should. That's your recurring rate. That's your slope. This was your one-time cost, your fixed amount, your starting amount, your y-intercept, whatever you want to say there. That starting amount will be referring to, in these situations, pretty much always, the initial point. So where does it start? It starts at 1200. If you want to view this another different way, actually, no, that's going to be about it. To view it a different way there. Same thing here, because I'm assuming m is minutes. So you could say at minute 0. So when m equals 0, this is the function notation part happening. So when you just start whatever's happening at minute 0, you replace all the m's with 0. And you would notice that, well, 450 times 0 is just 0. 0 plus 1200 is 1200. So at the 0-minute mark, your height is 1200. At the 5-minute mark, your height is whatever. That's all the interpretation here is saying. 1200 feet per minute, that would be 450 in this case. Pop at 1200, don't even know where that comes into play. It takes 1200 minutes to reach its maximum. This would be like a y value, and this would be an x. So that would be insane if it took 1200 minutes, because this wouldn't have a maximum. Number 2, same idea. C of h is how much it charges, where h is the amount of hours. They probably should have said that. Granted, I created these questions, so I should have said that. So in this case, we know that 40h, that's the recurring rate. 60 is the initial. So if your bill was 180, which equation correctly represents this? So your C of H value is going to be 180. They're saying after a certain amount of hours, the cost was $180. Now, off the bat, that's B, right? But let's kind of show why these other ones wouldn't be true. For example, they're saying after 180 hours, the cost was $3. I mean, that doesn't seem right, but if you use your equation, if you replace the 180 with h, multiply by 40 and add 6, it definitely isn't 3. Same idea here. 3 for the hours makes it cost of 200. Well, 40 times 3 is 120. 120 plus 6 is 180. So that's pretty close. And actually, in this case, looks like this one is 3. Looks like they may have just inputted it wrong. And then same idea for number, like letter A. Input 180 for H. You definitely wouldn't add up to be 40. So in this scenario, looks like it's just B. With these words here, we've been looking at a lot of linear. We'll start talking about exponential here in a bit as well. Linear will be that per each. So we saw that in the last two, I think was that section 1 and then in module 1, section 3, I believe. In that case, these were the linears, the fixed rate plus the recurring rate, fixed rate plus recurring rate. Exponentials they have a base that doubles, triples, whatever number the quantity. So these are often for bank accounts, simple interest, compound interest, those things like that are typically the exponentials. And then quadratics are your curve path. This will be like your real world situations. You take a ball, you throw it up in the air, or whatever comes up, it's got to come down. We'll talk about that here on example number 4. In this case, off the bat, number 3, this is just simply a definition question. These are exponential. Interest or compound interest is shown by an exponential equation. And actually, like if we look at number 5 and 6 real quick, we'll come back to number 4. Don't worry. This is kind of how we calculate simple interest. Compound interest is a little more different, but we don't have to worry about that on the TSI. Hey, maybe this looks familiar. This was from Module 1, Section 2, I believe, where you're increasing by some percentage or decreasing by some percentage, or your rates. Notice that the exponent is time. This is happening over much amount of time. We call P your principal amount, or how much you're starting off with. So for example, you buy a car that costs 25 grand and you lose 50% of its value each year. Which function models the value after some amount of years? So off the bat, 15%. Remember, we change that percentage to be a rate by dividing it by 100. You are losing 15%. So this value is going down, it's decaying. So your principal amount, so they use V of T in this case. Your principal amount was 25,000. That's what you started out with. You are losing, so 1 minus the rate after so many years, which in this case, you can replace that 1 minus to be 0.85. Same idea on number 6. I will say the only weird part, I might as well go through it. Notice that off the bat, it says it's triples, and then have your initial of 100, and then it says every 2 years. So your initial P is 100, so it can't be D. That word triples, that is your rate. That is what's happening on the inside right here. So off the bat, can't be C. The biggest question is how to represent this if it triples every 2 years. So if we are tripling every 2 years, that essentially means you're tripling once every 2 years. So W over 2. You triple once every 2 years. 2W means you're tripling this value twice per year. So it's kind of doing the opposite of what we want in this case. And let's come back here to number 4. The reason why I skipped number 4 for right now is because it does involve a calculator. On the way the TSI exam works is each question will give you a certain type of calculator, a normal 4-function calculator, a square root calculator, or a TI-84. So they want you to find the maximum height using your calculator. If you don't want to, you can also use the equation for vertex. So negative b over 2a. That will be the x value. And then whatever that number is, we substitute into here. If you're curious about this, please reach out to me. I want to show you how it works on the TI-84 though. Okay? So on your calculator, I went ahead and typed in the equation to my y equals just to save time. So you just type in what they give you. Now, if you do notice, if you click graph, it's kind of hard to see. Not much given for you. So I do kind of want to show you in real time how I affect the graph in order to reach the highest point. If you click zoom and zoom out, so option 3, it's still not there. If you do zoom out one more time, it's there, but that's kind of hard to see. So let's talk about setting the window. For example, there is so much space there that I don't need. Like the x's go all the way to negative 150, positive 150. The y's go all the way to 150 and negative 150. All I want is the top of this graph. So let's restrict what we see. So if you click the window button, which is right next to the y equals, we can restrict what we see. For example, I don't really care about the negative x values. Let's just start at 0. And, I mean, this is not going to go very far because I look at my answer choices. The biggest answer choice is 16, so we'll do 20. Same thing on the y's. This is representing height. It'd be really bad if your height was negative. Now, the max height, I don't really know what it was. I know for sure it's below 100. So let's say maybe 80. That was a guess. Just to show you, if I type in 60, we're really close. So let me type in 80. And you see that's a little bit better. Now, I can also kind of decrease the x's if I really want to. For the sake of time, I'm not going to. Next, now we have a good graph. You'll press second trace. Go over to maximum. It does a guesstimation of it. So it wants you to go to the left of the maximum. So you have to press the cursor. I'm doing this on my iPad, so it's not very good. Okay, we're to the left of the maximum. Press enter. Now go to the right of the maximum. Press enter again. And on your nice fancy TI-84s that they give you, you have to press enter once more. In this case, that's kind of it. So if you notice here, it's kind of hard to see because I can't really point it out without actually moving away my cursor. It says the max is at x equals 2 and y equals 69. That means when the x value is 2, which in this case is t, the height is going to be 69 feet. So in this case, what time does it reach its maximum height? At a time of 2 seconds. So using your calculator there is very helpful. You don't have to use a calculator, but it does save you a lot of time, especially that means you don't have to memorize a whole formula, which is always nice. Last one for this video, a little bit longer video, which is always fine, is domain restrictions. We have different types of functions, but with these linear exponential quadratics, the value of x can be any number in the world, all the way to negative infinity to positive infinity. That's not the case for all functions. Specifically, if we look at two functions, one of them being a square root and the other being a rational function or like a fraction. If you have a rational function, so in this case, we have that equation or we have this equation, I'm just going to write just some random value for x. It's really bad if your denominator is 0. You do not want it to be 0. 1 divided by 0 or any value divided by 0 is undefined. That's a really bad thing for your function. Same idea. For any square roots, you don't want the inside to work out to be some negative value. So if you take the square root of some negative number, it is also undefined. It gives you an error in your calculator. Same idea here. We're asking, where are you undefined? So I want to avoid the places where your denominator is 0 or avoid the places where your square root is a negative. Now, I didn't add a square root question, so I just want to kind of do one here to decide. If I had the square root of x minus 5, what are some numbers that are really, really bad? Well, negative numbers are really bad. So if the x value was like 4, square root of 4 minus 5, which is square root of negative 1, hey, that's really bad for us. Same thing, if the x value was 3, 2, 1, 0, or really any number less than 5. If the x value was 5, well, 5 minus 5 is 0, and the square root of 0, it's just 0. That's totally fine. So for square roots, you want to avoid the negatives. Now go back to the question. For the rationals, you want to avoid where your denominator is equal to 0. So number 8 is easier than number 7. So let's do number 8 first. You have the equation r of t, or t of r, is 300 over r. Where are you mathematically undefined? Well, you don't want this number to equal 0. And you only have just an r on bottom. So literally, when the value of r is 0, that's really bad for us. Because the 300 divided by 0 is not possible. Same idea for number 7. Where are you undefined? Except that this one's a little bit more weirder, okay? We have x plus 5 over x squared minus 16. We want to avoid values of x such that when you plug it into here, you square it and subtract it with 16, you get 0. So what numbers for x get you 0 in the equation x squared minus 16? Now, you can solve this using just some good old algebra. You can add 16 to both sides, then take the square root. You can do factoring. You can also use your answer choices. For example, let's look at B. If you plug in 4, well, 4 to the power of 2 minus 16, does that get you 0? Well, 4 squared is 16. 16 minus 16 does get you 0. So, hey, it's really bad if you're equal to 4. I want to avoid that. Now, the answer choice is not B, though. Look at D. What about negative 4? Let's do the same thing. Plug in negative 4 into the value of x. Well, negative 4 squared is negative 4 times negative 4. And a negative times a negative is a positive. And hey, it looks like in this case, it's also really bad if you're equal to negative 4. So for us, in this case, it would be the value of D. If you did solve for x by adding 16 and then taking the square root, that's kind of why we had to include a plus or minus with our square root, because it could be two separate values, a positive or a negative. Squaring a number automatically makes it positive. So we have to watch out for that with our square roots. A little bit longer video, but I hope it was helpful. If you have any more questions, be sure to let me know. If not, thank you so much for watching. Hope you have a great rest of your day. And as always, go Mavericks.